Okay.
Go.
Can I start?
Yes, go ahead.
Okay. Good morning, everybody. For those of you who don't know me, I'm David Ciardi. I am the project scientist for the SUI part of the data management, and I want to say thank you and also send my apologies for not being able to be there today in person. So I will try to give an overview of where we are and what our philosophy is for the science user interface. But Xiuqin, who is my technical lead, and the rest of the team should be in the room. If you all want to raise your hands and say hello, that way people can come find you and ask the really hard questions after I hang up and go away. I'd like to start with the overall philosophy. So, as you all know, Science User Interface, this is the entry point for the community to get to the data. And we want to be able to build something that is useful for both the expert and the novice users. The group of you are sitting in this room because you're all very interested in LSST long before any data will actually be collected. And so we want a user interface that will be flexible enough to meet the needs of each of you, who will all likely be some form of power user. But we also want the interface to be inviting and easy to use for those people who are new to the project, who've never even heard or know how to spell LSST prior to operations. And so the interface needs to be engaging both the group of you as well as the novice users. And so from that point of view, we wanted to make the SUI more than just a list of requirements. We wanted to make it a toolkit where we can mate the data and the user, and enable a set of creativity and flexibility. And this is very specific because there is no way that we can anticipate and build to all the needs and wants of the community. Each of you, belonging to the various science collaborations, has a somewhat different view of how you want to use the data, and building a single monolithic interface to meet all of those needs would be impossible. Instead, we do want to build a portal that sort of meets the needs of the general user. It needs to do really basic things, as you all know. It needs to search, it needs to have image visualization, it needs to be able to visualize tables and plottings. We want to have a workspace environment in which data are so large, people are going to bring all of the data back. And so we want to build this as a component set that'll be usable by others as well to build their tools they want to own special needs. And so towards that end, making this the entry point to the LSST data, we want to be able to people to discover their data, to be able to visualize their data, to be able to manage the workflow of their data, and that implies there needs to be a workspace, and then supply all of this software so that you can think about building your own interface in case the interfaces that we put together for the sort of entry point is not quite sufficient for your own specific needs. And so it's this whole philosophy that we've developed in the last 6 to 9 months since coming on board to the construction project, that the idea is behind all this is to build an SUI that does most of what you need to do, but do it in a way that enables you, the scientist, to do something very specific that you want to do. And so towards that end, the SUI is much more than just a single entry point, right? There's the APIs that will allow you to access the data. The APIs will have Python wrappers to make it more astronomy friendly, as Python is becoming more and more the standard within our field. Have a user environment, which is more like a workspace where things can get stored and things can get shared, where you can run code, where you can access the data where the data are. Also, we want to be able to, of course, visualize the data. and have some pre-developed set of tools, but also be able to run that visualization not just in sort of a single mode, but that you can display that visualization back to your home computer, or more importantly, back to a variety of remote clients. That you're sharing not only the information and the processing, but you're actually now beginning to share the visualization across across multiple users and multiple clients. And we can do this through the web browser, which is sort of the backbone beginnings of all this. But also now that we have, and I'll talk about this in a moment, but we're starting to really blend the visualization and the entire environment around Python. And so you can bring back the visualization from the workspace through an IPython notebook. We don't want the visualization to be standalone and you have to do something and then bring the data over and then visualize the results. But rather, what we're trying to do is build an environment where the processing and the interaction with the data is also interactive with the visualization. And so the next few slides are just some basic outlines of not only our thoughts on how we're going to do this, but the actual beginnings of where we are and the connections that we've made through the visualization tools and the interactions enabled to the users. And not yesterday, but the day before, if some of you were here, there was actually an SUI session where we helped, for people who were interested, help people to understand how we've made these connections and how you can start to build and talk about using the SUI tools in your own environments. So this is just 3 basic slides of how you can think about using the visualization tools. Right now we have 3 basic pieces of visualization which come out of development that we've done at IPAC through the Infrared Science Archive and what we've done for Spitzer. Basically, there's an image visualizer, there's a table visualizer, and there's a plot visualizer. But the 3 of them are connected. So if you do something in the image or you do something in the table, it gets reflected in the table or gets reflected in the plot. So the point is that they are connected, and the pieces are modular, where you can put together, okay, I just want an image, or I just want a table, or I want all 3. And these visualization tools can be put together into a web-based portal that meets your needs. But as the green part of this diagram is trying to indicate, is that it'll also be connected to the workspace environment and the overall environment in which the LSST data management system will live, and so therefore you'll have access to the workspace. You'll be able to share and bring things back. You say something, you bring it back, you save the query, however it works. And so this is, at some level, a more traditional view, because you put together a web-based portal, but it's much more than that, because it's not just bring an image over and display it in your client browser. It's the client browser is talking to the servers at the back end, and it's embedded within your own personal workspace environment. But then we've also expanded very strongly upon this, and so what we've developed is the ability to bring in the visualization tools within your own Python environment. So if you look at the figure on the lower left, you'll see this image of famous galaxy. But the point of this image is that it's actually inside an IPython notebook, and if you look above where it says Firefly, you can actually see that there's an actual Python that's brought up the visualization, right? And it says get Firefly, right? The whole point is that you're creating an IPython notebook. You're driving the visualization from Python. You're bringing back the information from the server and being able to interact with the the data and the image in the visualization within the IPython environment. So this is one way to very strongly connect our tools that we're developing with the needs of the scientists, which we can't necessarily predict. And this IPython notebook doesn't have to live on your client, at your desktop. On your desktop, it could be an IPython notebook running out of the workspace at the NCSA servers. It just happens to be displayed on your local machine. And so it gives the flexibility to you, the scientist, to do what you need to do with your research group or yourself and develop what you want to do while having server access to the data and without having to develop every single tool for yourself. And then sort of related to all of this is we've also started to connect the visualization tools directly to Python servers themselves so that you can create your own tasks, create a nice little JavaScript button that says something, and actually launch a very specific Python task. For example, it could be something out of the stack, say you want to rerun some of the photometry, or it could be something that you've developed on your own, and it's a whole slew of interactions that your set of code does, writes out the results, and it gets brought back into the visualization. And in this particular example, an area of the image was selected with the mouse within the web browser, but what came back after the Python task was launched and returned the information was a histogram. Right? So it's a very simple. This was a very simple example, but the infrastructure now is in place where we can start to begin to grow the visualization tools and the visualization experience because it's now also connected on the back end in a variety of ways. So where are we going? The last 6 to 9 months was about defining this vision. So one of the things that Mario sort of mentioned very briefly was that every single one of the people who are currently working on the SUI within the DM are all new to the LSST project. So we had to come in, we had to understand what had been designed and through prior to FDR and prior to construction being approved. And so we've done that. We've tried to understand how we want the SUI to be part of the LSST philosophy and the LSST environment. And so coming up, where we want to take this is now that we've established the basics of how to connect our visualization with the workspace environments and with the idea behind having the users access to Python and building their own environments as well as building our own specific portals for the generic user, we now need to start to begin to understand specific scientific requirements and needs for the individual science collaboration. So that we make sure that we understand there's something very specific that wasn't captured in the pre-construction requirements. And then slowly, we need to start educating the community and the collaborations on how to actually use these tools. So we're not quite there yet. We still have a fair amount of design work to think through, in particular, the workspace, exactly how it's going to work and how it's going to connect hasn't been thought through in any strong detail. But where I'm trying to drive this from the point of view of being a scientist, so I am a member of the Stars Milky Way collaboration as well as the transient variable collaboration. So I have a very strong desire to make sure that these work for my collaborations as well, but I need to also make sure that they work for the dark energy and the extragalactic collaborations, the galactic structure groups and the solar systems. And so each of these groups will have very slightly different requirements that they specifically need to do. So for example, the galactic structure people probably really don't care about redshifts, right? But everybody sort of cares about color diagrams, color magnitude diagrams. Solar system folks have things that move. Galactic structure folks really don't. And so it's these kinds of things, making sure that we have the right set of tools as they got listed in the requirements, things that we're missing, things that we think we should enable, but rather, or things that we think that we need to develop specifically. And that is all going to start taking place over the next 12 to 24 months. And so with that, I'm going to stop. I will emphasize that if you have technical questions throughout the next couple of days, most of the team will be there. I unfortunately had a personal conflict, and hence I'm giving this talk remotely. But please feel free, if you want to get a hold of me, send an email at IPAC, you can, or drop me a line or whatever. Anyway, thank you.
All right, excellent.
All I can see is Mario. There you go.
One question, maybe one question for David. Dominique.
Looks to me that there is an obvious connection with the previous talk, and especially looking at it is
so either somebody's going to repeat this or get closer because I can't hear well.
I'll repeat it.
Okay, I will repeat the question. So, it's more a comment. I think that there is an obvious connection with the previous talk, and especially looking at your slide, which is still on the screen, understanding specific scientific needs and assess the completeness. The engaging the science collaborations. So I think that what you are doing is a very good way to complete what the other David was presenting before with the precursor data set, in order to engage the scientific collaborations, in order to inject some expertise inside the assessment of the precursor data set production.
So I'm not sure how much of that you heard, but Dominic was saying that a combination of the data sets, process data sets that David Niederberg showed in the previous talk, and then the user interface, so loading them into the user interface would be a wonderful way to test the user interface and to engage the science collaborations.
Yeah, so I actually completely agree, and I've been giving this some thought. So one of the things that I'd like to do is, we have to decide as a whole, as DM, I'm looking at Mario, how he wants to proceed with, any one given data set. We could start with a more generic data set and build up the tools. But I also think that we should think through, if a particular data set is useful for a particular collaboration, instead of my team building the interface so that it does something that you want to do, rather use that as an opportunity to begin to train the collaborations on how to use the interfaces. And that would give us feedback from real users on, that just doesn't work, or that worked really well, or this piece is missing. At some level, also, we have a pretty limited team in terms of number of people, so we wouldn't be able to necessarily build 15 different interfaces. But we certainly can collect back information from the collaborations in a way that real world use. I think that's really important.
Okay, so we have thanks. Let's thank David once more. So we have one more talk.
I really apologize for not being able to be there.
Oh. No, thank you for giving the talk remotely. That's never easy. So.